Geometro Ninjas, and welcome to another beautiful day in geometry. Today we get to talk about conditional probability. So conditional probability is a little different than what we've been dealing with. It's a situation where it's the probability of event B occurring knowing that event A has already occurred. Now, this is a little different than what we've done with compound, okay? So this is different because the probability of B is going to be adjusted by removing a little bit of something that's already happened. So we've got to kind of take some overlap out. So the probability of event A has already occurred. There's a separate space for that, but who cares? Okay, so our notation is, you saw that given bar yesterday. So probability of B given A. So I kind of introduced it to you yesterday, but this is the way it's really going to be seen. And our formula is, it's the probability of B given A. So again, that's what you'll see in the problem. B given A equals the probability of A and B occurring divided by just the probability of A. So A has already happened. And now we want to know, what is the probability of A and B happening? Okay, so it's a little weird right now, but let's put some numbers to it, some examples to it, and see if we can't go ahead and figure out what's happening. Okay, so questions 1 through 4. Number 1 through 20 is chosen at random. Find the probability. So you got 1 through 20. Okay, you want to know a number that is prime given it is greater than 8. So let's kind of go over here to the side, and we'll kind of write out all our prime numbers. 7, 8. I'll try to stack them up nice and neat, but it looks like I've already lost my line integrity, and that's okay. Just make them happy trees, you know, Bob Ross style. 19 and 20. And then now we're going to go through, and let's just go ahead and highlight our prime numbers. So 2, 3, 4, 5, 7, 8 is divisible, 9 is divisible, 10, 11, 13, 14 is divisible, 15, 16, 17, and 19. So those are all of our prime numbers. We'll just go ahead and get that out of the way. So it wants to know the probability is prime given it is greater than 8. So the given is always my denominator. If we look at our formula, okay, so you had probability of B given A. So this A was your denominator, right? By what I just told you. Ooh, spell word, Sean. So, and then you look at our formula, and of course, A was in our denominator, A is there. So that given part, the given is my denominator. So we need the probability that a number is greater than 8. So when I go over here, we've got 12 numbers that are greater than 8. So the probability of that occurring is 12 out of 20. Now the first one, probability that it's prime, okay? So we need the probability of A and B occurring, okay? So prime is our B, so now we just need the probability of A and B. The greater than 8 was just our probability of A and B, so that means it's got to be greater than 8 and prime. So we look over there, we've got 11, 13, 17, and 19. So that's 4. So the probability of A and B is 4 out of 20. And now we're just going to plug those into our equation. So the probability of A and B is 4 over 20 divided by the probability of a number greater than 8. So the probability of A, which was 12 over 20. Okay. Now y'all can put that right into your calculator, and if you use parentheses, you're going to be great. But in math, we can't divide a fraction, so we multiply by the reciprocal. Great answer. So 20 over 12. Now the beautiful part about this is, because they both have the same denominator, we can go ahead and cancel out those 20s. And then we get 4 over 12. Now, if you want to be really saucy, you could have also reduced that fraction already. And then 4 over 12 reduces to 1/3. And then, of course, it can be expressed as a decimal, 0.33 repeating, or a percentage. Let's look at number 2. Probability of multiple of 3. So there's B. So this is probability of B. And then probability of A is our odd. So the probability that a number in this is odd, there are 10 out of 20. So the probability of A occurring is 10 out of 20. And it wants to know, of those numbers that are odd, how many are multiples of 3? So the probability of A and B would be odd numbers that are multiples of 3. So it looks like we've got 3, 6 is even, 9 is odd, 12 is even, 15 is odd, and 18 is even. So it looks like we just got 3 out of 20. And then we're just going to do our formula. So 3 out of 20 divided by 10 out of 20. Cannot divide fractions, so we multiply by the reciprocal. 3 out of 20 times 20 over 10. We can cancel out those 20s. And we get 3/10. Okay, next one, perfect square. Of our perfect squares, and at most 15. So the probability of getting a perfect square. Well, we already went through and calculated all those with those red stars. And, well, we did not. Let's make those blue stars. So perfect squares are numbers that are multiples of itself. So 4 is a perfect square. 9 is a perfect square. 4, 9, 16. And technically, 1 is also a perfect square. So 1, 4, 9, 16. That's when you multiply two numbers and it comes out to be a square. So 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. Those are perfect squares. So the probability of perfect squares are 4 over 20. Okay. Now the probability that it's a perfect square and at most 15, well, now 16 stops out of the equation, so we got 3 over 20. Now we go ahead and say, so the biggest thing here is, and as you'll see in some more, it's almost going to reset the denominator. If you're really seeing what's happened, we multiply by that reciprocal. And we look at our last, we'll finish this one first, and then we'll come back, I'll come back to my point. But can't divide fractions, so you got to multiply a reciprocal. So 3 over 20 becomes 20 over 4. So it is 3 divided by 4. So if you look at the 3 we've done, number 1, number 2, and number 3, we use the probability of our total sample space. But when we did this given, guys, instead of doing all of it, we reduced our sample space. So when you look at 4 divided by 12, let me put my tail on there. So we look at 4 divided by 12, we know there were 12 numbers greater than 8, and of those 12 numbers, 4 were prime. The same thing occurred in 2. We know there were 10 numbers that were odd, and of those 10 numbers, 3 were multiples of 3. And then our next one, we've got perfect squares were 4, and of those 4, 3 were at most 15. So when we're doing conditional probability, okay, we are restricting our sample space. We're taking the total sample space and we're minimizing it. So as you continue to progress through this, you're probably not even going to need that big formula anymore, but it's good to keep practicing. Now, we look at the next one. We've got 8 marbles, 8 red, 2 blue, 4 yellow, and 6. If a marble is drawn at random, so first off, let's add them together. 8, 2, 4, and 6. There's 20 total marbles in that bag. If a marble is joined at random, find each probability. So let's just do it our old way first, and then let's see if we can't figure it out as we go. So not blue. So the probability that this thing is not blue would be 18 out of 20. And then the probability that it's not blue and is red. So of the markers that are not blue, or the marbles, I don't know why I get the words confused. Of the marbles that are not blue, how many are red? Well, the not blue doesn't even change because there's 8 red marbles in the bag. We're going to go ahead and set up our formula. So A and B divided by just A. Cannot divide fractions, so we got to multiply by the reciprocal. Oh gosh, what are you doing? 20 over 18. Our 20s can cancel. We got 8 over 18, which is 4 ninths. 4 ninths. So look at it, guys. Not marbles that were not blue in this bag. There was 18 of those. Our new sample space is those 18 marbles. And then of those 18 marbles, 8 of them were red. Number 6. Probability that it's yellow given that it's not white. So the probability of A occurring, the probability of not white happening would be 14 out of 20. So there's the new sample space for our probability. But let's find out. And then of those, how many are not white and are yellow? Well, that would be there were 4 out of 20 that are not white, but are yellow. So 4 over 20 divided by 14 over 20. Can't multiply or can't divide fractions, so we're going to multiply by the reciprocal. 4 over 20 times 20 over 14. And then 4 over 14 reduces to 2/7. Now another little trick here, guys. Let's say, man, coach, I forgot to cancel something, or I did something funky. Always remember that our probability, there goes the light, will always be between 0 and 1. So if you end up with a number that's greater than 1, you've done something wrong. So go back and figure out what's happening. All right. Number 7. Actually, let's go to number 8. No, let's do number 7. Spinner on the right is, our spinner on the left is spun. Find the probability that it is shaded given it's a vowel. So we need the probability that it's a vowel. And on this wheel, we've got 16 spaces. And of those 16 spaces, 4 are vowels. Now, and then A and B. So how many of them on this wheel are shaded and vowels? So A is shaded and a vowel. E is shaded and a vowel. O is shaded and a vowel. So 3 out of 20. So 3 out of 20 divided by 4 out of 16. Can't divide fractions, so we multiply by the reciprocal. I don't know why I put 20. I've been writing 20 so much. So 3 out of 16, my bad, guys. 16, ooh, sheesh. 3 out of 16 times 16 over 4. Okay. Remember, our denominator is going to cancel. And we get 3/4. So this conditional probability, guys, sets a new sample space. So for number 9, I'm going to go ahead and show you my little short way before we go through and do the long way, and that's completely fine. So a card's chosen at random for a standard deck of cards. Find that the card is an ace given it's a diamond. So they want probability of ace given diamond. Let me go ahead and draw that A out so it doesn't confuse you guys. And you're like, Coach, I thought you said probability of A goes on the right side. My bad, yo. Okay. Ace given diamond. So there are 13 diamonds in the deck, right? 13 diamonds in the deck. And of those 13 diamonds, there is 1 ace. So my prediction for this answer is 1 over 13. That's my prediction. Let's find out. Because I'm saying, hey, diamond is my reduced sample space. Of those diamonds, there's 1 ace. Let's go ahead and see what happens in the Thunderdome. So diamond, the probability of pulling a diamond out of a deck of cards is 13 out of 52. There are 13 of each suit. And then the probability of pulling an ace, and it is a diamond, so A and B, is 1 out of 52. There's only 1 ace of diamonds in the deck. So 1 out of 52 divided by 13 out of 52. Uh-oh. Could it be? Can't divide fractions, so we multiply by the reciprocal. Sean, what are you doing, man? Okay. 52s are going to cancel nice and pretty for me, making my life a little easier. And look at that, 1 out of 13. And remember, guys, it can be a decimal or a percentage. Let's go ahead and go to page number 2. Let's use it. Oh, this percentage one is good. We're going to talk about the percentage one. A car lot has got both used and new cars. If 86% of the cars are new and 45% are new and have a sunroof, find the probability of randomly choosing a car with a sunroof given it's a new. So probability of sunroof given, I tried to finish the word roof. Oh goodness. Oh goodness. I did almost finish the word roof. I kept going. Sun given that it's new. Okay. So the beautiful part about these percentages is it already told me both. So probability of a new car on the lot is 86%. The probability of a new car that has a sunroof was 45%. So we're just going to convert these to decimals so we can solve them mathematically. So 0.45 divided by 0.86. And we pop that into the L calculadora, and we get 0.523. Or, if it really wants to get technical, 52.3%. So guys, in these word problems, there's a lot of times they're going to already give us A and B, and we just got to figure it out. So Venn diagrams can get a little tricky and a little annoying, but we're rock stars. We're going to crush it. We're going to get after it. Okay. So a group of people asked if they drank coffee or tea. Results are shown in the Venn diagram. One of the people surveyed is chosen at random. Find the probability of each. Find the probability that it drinks coffee given that it's tea. Now we could go through and do that big old long formula, but let's go ahead and reduce our sample space. So this is what we're going to reduce our sample space into. We only want people that drink tea. So if I were looking at only the people that drink tea, okay, what an awful circle. Okay, I only want the people that drink tea. That's 16 people, right? So that would be my new denominator. There are 16 people that only drink tea. Now, out of those 16 people, how many drink coffee? Well, 4 of them only drink tea, and 12 of them drink both. So 12 over 16 reduces to 3/4. So the next one. Oh, come on, eraser. Does not drink tea given they drink coffee. So there's our new denominator. Who drinks coffee in this thing? So we go back to the highlighter. Oh my goodness. The circles are off to date. And we go back to our highlighter. How many people that were surveyed drink coffee? Well, the answer to that question is 36. And of those 36 people, how many do not drink tea? And the answer would be 24. They only drink coffee. 24 over 36 reduces to 2/3. And then our last problem here. Drinks coffee and does not drink tea. So now it's going to be a little different. How many in our survey do not drink tea? Okay, so that would be the 24 who only drink coffee and the 10 who don't drink either. So our new denominator, our new sample space is 34. And of those 34, how many also do not drink coffee? So we can go ahead and take that 24 out of the equation and just get 10, which is 5 out of 17. All right, now we get to make our own Venn diagrams, which I know is our favoriteest thing in the world. So we're going to go ahead and do our universal set. I've got a circle here. I've got a circle here. Oh my goodness. I'm only making it worse. I'm only making it worse. Okay. It wants to know 400 freshmen at Westview, 92 are in the band, 60 are in course, 20 are in both band and course. Okay. So we've got, so this can be set band. This can be course. We know of those students, 20 were in both. It told me that 92 are in band, but we've got to subtract the 20 that are also in course. So our total is actually 72. It told me that 60 are in course, but because we know 20 are also in band, we got to take those 20 away. So we get 40. And then down here in the handy dandy rest of the world, what do we got? 72 plus 20 plus 40 minus 400 freshmen. Man, that's a lot of freshmen. 132 total children that aren't band or course. The chillins. Okay, so in the course, given they are in the band, there's our new denominator. How many kids are in the band? Well, it told us 92 students are in the band. Okay, and of those 92 students, how many are in course? What is our A and B? So that would be that intersection right here. So that would be, of course, 20. 20 over 92 reduces to 5 over 23. Okay, our new restriction, our given is in course. We had 60 students that were in course. Of those 60, how many were not in band? So now we want only course, which would be that 40. That reduces to 2/3. And then finally, we want who's not in course. That's why we got that big ginormous number over under. So that would be the 72 and then the 132. Because they are not in course. Did I add something up, bro? Oh, I did. I forgot to subtract from 400. Why didn't one of y'all stop me? Come on now. I know this is pre-recorded, but y'all should have had the fruition to know that Coach O was in trouble. You silly rascals. Okay, so we add up our 72 and our 268, which gets me 340. And of those 340, how many are in the band, which would be 72. Math frac that rascal. 18 over 85. Guys, that completes our lesson on conditional probability. Go be great today.